Okay, welcome everyone. I'm going to start today's session. Today we will be continuing the previous class, and in the previous class we talked about simple panel data model and data loading and graphs for basic data. And the background of that data was that the data is not long enough, means there are many countries, but their years are few. So we call it static panel data model. So in this video, we are focusing on dynamic panel data models, and we'll start with the models which are with the libraries which are available in the Python. In this session, we'll be only focusing on the models which are available in Python, and in the future sessions, we will plan to have a new session where we learn how to make models which are substitute of the models which are already available in other softwares. Okay, so we'll start with examples today. So first of all, we'll start with some libraries. So there's one library need to install that is called linear models. So I will install it here. And when it is installed, we come towards loading the libraries, and there's another library to be installed. So and I'm loading the libraries for pandas, then stat models for Dickey Fuller test, and NumPy for calculation of new variables, then stat models for ADF and KPSS, and then Arch unit 2 test. Okay, then I load the data file which is already shared to you, and I will make sure that it is here. Okay, so this data is exchange rate data downloaded from Penn World Tables. That's why its name is Penn X rate. So first command will read the data file from the folder. Second will convert it into panel data. And drop false is important because if you don't do it, it will delete the cross section and time variable, and you might need it in future. And then it prints the head, means first five rows. Okay, now we move forward and we look for other points. Then there is a graph that if you want to plot the time series versions of the data, you can use this plot. So you need to import the matplotlib library, which is used to import the data, which is used to plot the graphs. Okay, and then we filter only first 10 countries because in my data there are too many. If I plot all of them, then what will happen is that we will not be able to see the graphs. You can pick few countries, you can make a list and then filter, or just say first 10 countries, or print one country one at a time so that the graphs are big enough. So what I did, I create a new data that is unique. It picked up the ID variable from the data and picked first 10 unique IDs, means first country to the 10th country. And then it started with setting the axis. So it should be, I need to add 10 graphs. So I should add 2 rows and 5 columns, and then I will flatten it so it is adjusted for the graphs, and then I will pick it up for I from country ID. How I pick the country ID? Country ID is from enumerate first 10 countries, so it will just count it from here. Okay, and then for each country ID, it will filter the data. So country data is equal to data, which is filtering the data's ID variable equal to country ID. And then each graph, it will plot here on the x-axis and the x rate on the y-axis, and then it will print the country name as a head title. Okay, and then it will add x-axis label and y-axis label. So when you run it, you will see graph data for each country. So this way you can plot a time series data on or for a panel data. Okay. Next is if you want to calculate dummies in the data. So what you can do is that you can write my data file name is data, and I will name it as a new variable. I will call it dummies. Okay, and then what I want to do is that it will get dummies from the data, and data name is data, and it will pick up the variable. So I will convert the country variable into dummies. So as the dummies are already there, its name is ID, but I wanted to learn how to make a new variable. So drop first, we don't want to drop it. Okay, I don't want to drop the country variable. So when I run it, let's see what variable error does it again. So multiple column with single column dummies. So explain the error. Let's see what does it need. So let me say it is saying us to yeah. So it is saying that it will make a dummy for each country. So we need to have a prefix, and then it will merge the data. Okay. So I will copy all the codes, and rather than this line, I will make this. So this way I have a prefix. So it will be country underscore one, country underscore two, and then it will make the data set. So if I run this, let's see. So it has made it. Let's show the data again. Data dot columns to see how many columns are there. Okay, so see, so it has columns for each country now. So you can see country code. So since I picked up this variable, it has a country symbol. So it has picked country underscore symbol. So there are like 170 variables. Not it is not showing all of them, it is showing first 10 and then the last 10. So this way you can confirm the dummies are made. Okay. This way you can make dummies if you have a binomial variable or a multinomial variable. Next we go towards discussing the unit to test. So unfortunately in the Python there is no panel data unit to test. There is time series unit to test. So how we do it? So it will do Fisher ADF test. It will do a Fisher ADF test, and it will pick up the exchange rate variable and apply 3 lags. Okay, and then when it runs the data, it will store it for all the variables. So I have made a loop for all the IDs, unique IDs, and then run this model. So when I run it again, so it will show you. So it is X. The X is required. Okay, so some of the code has been changed. Let's see. So it is saying that you need to add another line. This you need to add make a new data set which is empty, and it should be shown somewhere. Let's see. It should be shown after second heading. Store of the yeah. Look at this. Okay, and then you need to change convert into. So but if you're not able to understand, just you can just copy. What I usually do is I first of all look at what's changed. So this line I already have. This line is some new line. Okay, and country data equal to 0, and this part is new. So from here to here. Okay, so what I will do, copy this. No, so this is for IDX, copy. Okay, and then because this line is not there anymore, I will remove it and add this line. So when I run it, let's see. So data frame has no attribute unique. So what I will do, explain the error again. So it is saying country data is equal to IDX, convert into series. Yes. So I will just copy this and replace it. So yeah, so it is what it is doing. So it for each country it will give you the test value and its p-value and the critical values. Okay, so this way for all the countries it is giving. So this is actually doing a time series unit to test for each variable. Same next is that it focuses on if you want to create a log. So it's an example to generate log of the data. Okay, and now it is giving the same error. So why it is giving error? Because data already has data of LEX. So if I go on the top, I will show you it's somewhere here. Yeah, so this data is already there. So before that's why it is giving error. So what we can do is we can have a look. So data dot head bracket open and close. So when I have a look, it will show you that these variables are there. So if I run this, okay, then we will have a look what new error is there. Okay, so it said it should be float. Why? Because if the data is not numeric, it will not apply log on it. Okay, so what I did, I added this as type low float. So when you do it, it still gives again the same error. Let's check it again. Now, after that, we will focus on one of the dynamic panel data regression. Before that, if you have any question, you can ask. I will try to visualize or do that activity, and then we'll go towards the next step. We'll just separate it into two sets and have a look where is the problem. So it is not able to convert it into numeric. So I need to have a look here.
Assalamu alaikum, sir.
Yes.
Thank you, sir. I have a question. Can we use the Google Colab in order to merge two data sets by generating the codes with the help of AI?
Yeah. So the example I will show you one example. So let's move on that because this data file I have to import it again so that this can be sorted. So we will build on this example. So let me open up the data files, show you two examples, and then we'll focus on how to merge it. Okay. So in this example, the I was going to do it, but let's start it here. So let me open up the data files. So we have this data file. So I will show you one example, this one. So this is one Excel file, and I will show you another Excel file in which there is a data that I can merge because sure. So this is another file. Let me bring it here. So both are panel data, but the problem with this data file is that it doesn't have full country names, and it has the full country name. So in order to merge it, you need to convert these country names into full names. Without that, you cannot merge them together because the identifier does not properly match. Okay, and so for that, I will open another example where there is an option to merge it. So let's open this one file. This file cannot be merged also. I will go to another example. You have this data file. This is also individual data. You have this data file. Yeah, it has the country names. Okay. So I will import this file and the other file that I talked about. So let's go to Python. Minimize this. I will load those two data files. So first data file is that JSA2. Okay. And second data file is okay. Press OK. And the second data file is Let me go back. This is the data. Okay, both of the data are loaded, being imported. So what I will do, I will first of all read both data sets. So data 1 will be equal to, so the command includes pd dot read. Okay, so we'll come to, yeah, pd dot read underscore excel, and I will write the data file name, that is jasa2.xlxsx. So this will be the first data file. Okay, xls. Okay, and I will override the other command to here too. Data 2 is equal to pd. Okay, so I will run both. It says the Excel data. Okay, the spelling mistake. So both data sets are imported. Okay, I will press it here. I need to merge both data 1 and data 2 based on their, let me see what were their identifiers. I can add a code here. Data 1 dot head, need to know the exact spellings. So the first country, its nation and year. Okay, and for simplicity, what I can do is I can just add a new variable, data 1 country is equal to data 1 nation. Okay, so when I press it, it will convert. So I should move it up so that it should visualize after I have done it. So you will see there's a country variable. Okay, and then I need to see the second data file also. So data 2 dot head, bracket open close. So it has a country year, so same variable. So based on the country and year identifier. So there are three types of merging, three major types. One is left merge, another is right merge, and then there's a full merge. So if you do the left merge, it will focus on the countries which are in the first data file only, and if the second data file has some new data sets, it will not merge it, new countries. And if you do the right merge, it will pick up the second data file and then only use merge those which are available in the second. If the first one has a new country, it will not merge it. But if I write full merge, it will merge both data files. If like one country is not available in the other, it will still use the data and merge it. So I need to full merge both data files based on country identifier. So when I press enter, so merge data, PD merge
Sir,
data 1, data
sorry,
2.
sir.
Yes.
Sorry to interrupt you, sir. Actually, the inner part is showing the, sorry, the full part is showing the inner section, right? The inner
No,
command.
no, the full is inner. No,
Okay, outer.
I'm using outer. So outer means that if
Okay.
both data files has some different countries, it will still keep it. It will not remove. It will do if you do the inner, it will only use the common countries in both files.
All right,
Okay.
sir. So
Okay.
this is the best way to use the outer section,
Yeah,
right?
so I usually do outer because sometimes if you have a country name error, for example, in this file, UK is written as u.k, but in this data file, it is United Kingdom. So if you use the inner, both UK and United Kingdom will be deleted, but actually they should not be. So what I do, I use the outer and then download the file and check if there is any country which is not properly merged. I will show you that example. So first of all, I will merge the data file. It has been merged. So I will ask it to download the data file. So download the merge underscore data file. Okay, so it will show me how to merge it. So when I run it, it will make it available here, or it is somewhere here. It's also here. So when I open the data file, so what is the common issue when you are merging? I will show it here. So I'll convert yes, close this old file and bring the new one here. So in this file, you can see that for Afghanistan, the second data set is here, first is not here. It means if I had used the inner merge, Afghanistan, Albania, this country would have been removed. And then see, there's Australia. Australia is here. It's also here, but its data is missing. Its data is here. So, so why it is not here? Because the second data set is starting from 2008, but the previous data set is finishing at 2013. Okay, then there is Austria, and this is here. So unfortunately, the both data set does not have a common year. So the one first data file is finishing in 1993, second is starting in 2008. So if they had common year, then you would have seen data one here and data two in front of it. So same way it goes down. So we have Belgium here and Belgium here. So but these countries you can see Bangladesh, Bahrain, they are not here. So it means first data file does not have these countries. Now we go down Brunei, it's not here in the first data set. Similarly, these countries. But there are some countries where there is a spelling mistake. So I will show you one example here. So let's if I go down, let's see Egypt is here and Egypt is not on the other side. Let's go to the to see the UK data. So let's go to the end. We will go up. See the United Kingdom is here and US and USA. So they are not merging because software does not recognize. So what I do is first of all I only merge the data file where there are common years. Otherwise it's not useful. Second, when I merge, if I know that there are only few countries where country spelling would be different, I merge it first and then copy paste to correct it. Otherwise, I first of all make sure that the both data files have same way of writing country names. For example, here Yemen is written as Yemen, comma Republic, but in others maybe in some other data file it will be Yemen only. Okay, so this can be a problem. So this is the major issue when you are trying to merge. For example, the new name of Turkey is Turkey, and the old name is Turkey. So if you don't know and you have not corrected, then it will never merge it. Okay, and then some other examples you can see. So Syria is Syrian Arab Republic, but in some other files it is only Syria. So they have written Swiss, but it should be Switzerland. So it's different. So this is the problem that you need to address when you are trying to merge the data files. I hope you got the answer. And if you have any
Yeah,
other
Jazakallah, thank you so much.
okay. So let's go back to the file. Say don't save. Okay. So that's the thing. That's why I use the outer, not the inner, or not even left or right. Because if I use the left and in the right file, if the country name is different, it will be dropped. And if I use right, then the first data file, it will be dropped. So I try to avoid it. So I use the outer to make sure if there is any issue. If there is an issue, we can see in the data file. Okay. And if you have any other question, you can ask. Otherwise, the class will be closing, so we will do in the next session. So we will take a break for 5 minutes here, and then we will be join it again in 5 minutes. So I will continue again. So I said that when I in the before merging, we were talking about taking a log of the data. So what the problem was that some of the process were done and the data lost its shape. So what I did, I imported the data again. Now it has converted the data into log. Okay. Next is that we will talk about the GMM models in panel data. Okay. So for that, I will show you examples here. So first of all, we need to install the library that is pydyn. So it's a PD. So it's dynamic panel data. So I have shared it here. Okay. And when it's installed, then we see the data head. So this is our data file. We have to now, before we run the panel data models, we need to generate the lag of the dependent variable. So what we are doing here is that I will show you how to take a lag. So the data lag one of X-ray is data group by ID. So why we need to group it by ID? Because if otherwise, if we take a lag, then it will not consider the country change and it will not create a gap. Okay. So you have to group it by and then shift one. So if you need one leg, you apply shift one. If you need two legs, you apply shift two. Okay. So I had created lags for both variables. Just an example. Okay. Then if you need to make sure that data is not working properly, you need to make sure that data is numeric. You can check it first of all by using command data.d types means data types, and you need to make sure that your data is either integer or float. It's not a string or any other type that is not numeric. Okay, so but you can convert it into numeric using this command, and then you can check it again. So data.d types or run the previous command again. So it will show that they are all numeric. So float and numeric are same thing. So only difference is when you say integer, it means that it will not go into decimal points. If you use the float, it can go into decimal points. Okay, and if your data does not have a decimal point, so it will consider it as a float integer variable. Okay, and see the country is an object. It can be a string if it is mixture of one and numbers and alphabets. Okay, then need to remove the missing values. Why? Because when I generated the lag, I will show you why I'm saying. So data dot head, I will show you first 30 values. So when I generated the lag, so it will have a NA value on every country's first observation. Okay, so this will have a issue in estimation. So what I did, I used the command drop NA, and I focused on these variables only because there was a I need to focus on this because I'm using these variables. So we'll drop NA. Then I load the library for the GMM and then pandas, and then I had reset. So this command is there in the start. I use the index to declare the data as a panel data, but I am now undeclaring it so that the command can use it itself. It does not need the declaration. Okay, then the background command is x-rate, exchange rate, lag of exchange rate, PPP means purchasing power parity, and then this is the lags that are used as an instrument for this exchange rate, and this is the lags that are used for this variable, and I have independent variable instrument variable CAPT also. Okay, this is the model for difference GMM. So when I run it, you will see that there are 8 instruments. Okay, okay, and then there are 151 countries and 31 years per country and 4,681 observations, and these are the coefficients, and you can also see the AR1 first difference values. They are all insignificant, means there is no what you call it, no autocorrelation in the model. And then there is Hansen over identification test, so it is also insignificant, so it's saying it's not over identified. So this is the two-step GMM, and we can also use PPP as an exogenous variable by adding its lag rather than using the level variables to break its if it has an endogeneity. So this way, this variable is here. Same thing, there's no autocorrelation and no over identification. Okay, so you can add more variables here if you want. So this is also again system GMM model. No, difference GMM. Then there's a system GMM model, and the difference is that it will does not have a no level, and then all the commands are same. So dependent variable, lag of dependent variable, independent variable, and then the GMM equations and the instrumental variable. Okay, and if you run it, it will show you that there is no autocorrelation and no over identification. So this way you can estimate the GMM model. So this was the example. So the for the people who are good in panel data and are Python, there's a huge scope in Python that you can develop the panel data models and make libraries in Python. So currently, Python does not have a huge set of libraries where you can apply advanced panel data models. So this was our session for today. Next thing I wanted to discuss is that you have any queries, you let me know. I will try to explain it here, and and then we will conclude today's session. So the floor is open for you. If you have any questions, you can ask. I will try to find examples and show it here. You are welcome to open the mic and ask any question you want.
Hello.
Yes, yes.
Sir, I would like to ask in the Excel file which you have shared, that is pan X rate,
Mm-hmm.
it is having many cross sections of different countries.
Mm-hmm.
So, can we try to have experiment on this by using CSARDL or
Yes, but the you have to do it manually because this model is not available in Python.
okay, okay. And you
Actually,
mentioned that we can change the runtime uh, from
yeah,
Python to R.
yeah, you can change it to R. Yeah, but R still does not also don't have the second gen CSARDL model. It can have
Okay, okay.
change the runtime to R, and then you can work on your model. So here, what I'm talking about that the Python is actually designed to go towards the machine learning side of data analysis. So it does not go deep into advanced, especially advanced panel data modeling, and so you don't find ready-made libraries. But if you explore GPT and you ask it, it will help you to how to make the code. So it means if you let's say you try to make the FMOLS model, if you asked GPT, it will tell you how to run it. It will give you a long set of codes, and then if you execute it, it will give you the answer. But the problem with that command is that then it's not feasible or possible to show it here because it will be too long and nobody can follow it how to do it. So what we can do is that in the future there will be I will be have another session where I will try to share the models that I have tried and already made their commands so that you can just adopt the codes and run your models.
Okay, sir.
So if anyone who have a question, you can raise hand and ask the question. Otherwise, what we'll do is we will try to conclude. So there's a question, which GPT is best? Technically, all of them are equal in terms of when you if you are learning the coding because it can for the easy models it can give you the code, but it depends what you're trying to ask. So I will try to share some platforms which can guide you. It depends upon how you asking. So what are you asking? Then it will. So the question was if DeepSeek is better or GPT is better. Technically, for me, if you are trying to get a write-up out of it, both are equal because DeepSeek is better in logic. So if you are asking logical thing, then DeepSeek will be better. But if you are saying that write me an introduction on this, I think both of them are similar in that domain. So it depends upon what you are trying to ask. Okay?
सर एक सिंपल सी डाउट थी
Yes.
like next time in future can you demonstrate some of the papers like from energy economics or FRL as to how
Uh,
we can replicate them.
yes, but for usually what I've noticed that most of them don't show you whole codes. They only show you the last step because the journal
Okay, okay.
requires them to make sure that they are replicatable. So what they do is they make sure that the data file is all the transformations are already there. They shade the final data file and they apply the final model. So the mostly don't show the whole transformation, but what we can do is you can share in our group and first of all try yourself. If you are not able to do, share in our group. We will see, or I will try to make a tutorial out of it and tell you how to do it.
Okay, okay, sure, sir. Thank you.
Okay, if there are not many questions, then what I do is that we will conclude our session for today so that I can compile and share it to you as soon as possible. So I would like that you should try, for at least you try these models for visualization and data handling. The first place, the major advantage of Python is that it's not only that you do analysis, it can connect your output on a website. You can show it on the website. You can compile it into a PDF, or you can connect it with some other software where its output can be used for decision making. So that's the thing with the Python that's not available in EViews or Stata. So that's why people are shifting towards it. And when the majority are shifting, then you will also notice that the new models are being developed and shared in Python. Okay. So I will conclude today's session and we will see another some other time and with more types of tutorials. Thank you. So there was a question, what are the precondition, the conditions just so how do we check preconditions? What preconditions you are trying asking about? So let me give me a hint. I will clear it here before closing. Yeah, like assumptions of GMM. So preconditions is actually there are two types of GMM models. First GMM model is that technically the GMM model can also be used when there is no endogeneity as a simple regression because it's a type of a method of moments regression, so you can use it. And then there are two reasons why people mostly use. First is that either there is endogeneity in the independent variable. Okay. Second is that you add the lag of dependent variable as an independent variable. Both are different symptoms, but their consequences are same, that they both lead to endogeneity. So in both cases, we apply GMM. And the examples that I showed here is applied when you had lag of independent variable as a lag of dependent variable as an independent variable. Okay. So this lead to use of GMM. So in that there are two types of GMM models. First is system and then difference. So these two models have been showed. If you want to go in detail, so you can see that I will share the link for the tutorial in which I have compared all the available GMM models in Stata and given its derivations and background discussions. So you can learn from that side. Okay, I hope you got the discussion. What kind of post estimation visualize you can do in Python? So you can do many types. It depends upon what are the outcomes that you get. Suppose when I do an estimation and if I have a square variable, I can calculate the cutoff points and then I can visualize. Suppose I am using the quantile regression, then I will run the regression at different other quantiles and I can plot the coefficient at different quantiles. Suppose I have using simple regression, I can generate the residuals and then check if the residuals have outlier or not. I can plot that. And suppose I have a moderator variable, then I can apply the moderation effect and show the graphs. So you can do many things. It depends upon what is your imagination, how you can handle it. I think you got the answer. So if you anyone else has a question, do let me know. Otherwise, we'll see each other some other time. Thank you.